This video is on colligative properties. Colligative properties are properties that are dependent upon the number of solute particles, which are ions of the solute, and it does not depend on what kind of solute it is. It just depends upon how many ions that solute can make. So this has to do with solutes dissolving in solvents and the effect of that solute being dissolved on the solvent. We can change our freezing point and we can change the boiling point of a solution. Freezing point depression is the freezing point being lowered when a solute is added to a solvent. We have an increase in malal concentration, which reduces our freezing point. So if the malal concentration is increased, our freezing point depression is decreased, so we can lower our freezing point. To do this, we have a few formulas. My change in freezing point is equal to the Kf value, which is a constant given here, times the molality of my solution. Then, to find the new freezing point, we take 0 degrees Celsius, because that is original freezing point of water, and we subtract from that the change in the freezing point we find here. For example, what is the freezing point of water in a solution with 17.1 grams of sucrose and 200 grams of water? Well, the first thing I need to do is find molality, because my change in freezing point is equal to Kf times molality. Remember, to get molality is moles of solute per kilogram of solvent. I need to get moles of solute for my 17 grams of sucrose. So 17.1 grams of sucrose The molar mass of sucrose is 342. So I get 0.05 moles of sucrose. I also need to change my 200 grams of water into kilograms. And now I have my numbers in units that I can use in my equation. So molality is my moles of solute divided by my kilograms of my solvent, and that equals 0.25 moles per kilogram. This is going to go here in my formula. So now to find my change in freezing point, I take change in TF is equal to Kf, which is my constant here, my 1.86, times my molality, which is 0.25. When I multiply the two together, I get 0.465. My units here are degrees Celsius. This means that my change in freezing point was 0.046 degrees Celsius. This is a negative value here. So it went down 0.46 degrees Celsius. So if my original degrees Celsius is 0, my original freezing point, and I went down 0.465 degrees Celsius, means my new freezing point, my TF, my new freezing point is negative 0.465 degrees Celsius. Now I can do a similar calculation with boiling point elevation. Here the difference is my constant, Kb, which we'll use instead of Kf before, B for freezing. My Kb value is 0.51 degrees Celsius kilograms of water per 1 mole of solute. To find our boiling point, normal boiling point is 100 degrees Celsius, and we'll add our difference that our solute made. It's good to note that the boiling point elevation, boiling point goes up as our malal concentration goes up. So here I want to find a solution that has 10.3 grams of glucose dissolved in 250 grams of water. What is my new boiling point of the solvent? Well, again, I need to find molality first of my solution, and that I'll multiply times my Kb value. Molality I know is moles per kilogram, so I first need to change my 10.3 grams of glucose to kilograms. My molar mass of glucose is 180 grams, which gives me 0.0572 moles. My grams of water, which is my solvent, I need to convert into kilograms. And now I have my units correct for molality. So my molality is my moles, my 0.0572, divided by my kilograms, 0.250, and I get a molality of 0.229. This is moles per kilogram. This molality gets put into my equation, so delta TB is equal to Kb, which is my constant, of my 0.51, times my molality of my 0.229, and that gets me 0.449 degrees Celsius. So my change in boiling point is a positive 0.449 degrees Celsius. So my new boiling point is 100 degrees Celsius plus my change, which gives me 100.449 degrees Celsius as my new boiling point. You'll notice that it takes quite a bit of our solute to have a significant impact on our change in boiling point and freezing point.